Let's take a look at solving trig equations. So unlike identities, where we were proving them true for values of x, trig equations is finding when they are true for specific values of x, I guess. So finding when, going to the most basic type, I guess, simply when tan theta is minus 2.3673. Question we now have to ask ourselves, of course, is which quadrant are we in and things like that. So they usually give us a domain to search. So 0 to 360 is the most common, because that being, of course, one complete circle, or one complete revolution, I should say, around the unit circle. So the first step, okay, locate the quadrants. So we'll be saying, right, I know I'm in the second or the fourth because tan's negative. Then we want to find the appropriate acute angle that we can convert it to. So tan alpha, I change the pronumeral because obviously it's not the same angle, and just make it positive. And we get 67 degrees 6 as the acute. So then I can go and solve our problem. All right, so there's my little unit circle. I know I'm in the second and the fourth, so there's my acute angle placement. So it'll be 180 minus the acute angle, and 360 minus the acute angle, giving me my two answers, 112.54 and 292.54. Cos theta equals a half is a lot easier, of course, because it's one of our exact values. But again, they've specified between 0 and 360, so I know I'm in my first or fourth quadrant this time. The acute angle would be 60 degrees, so first quadrant is just normal. Fourth quadrant, 360 minus the acute, so we have 60 and 300. Cosec. We don't have a cosec button on our calculator, of course. So the first thing we need to do is convert this into something we can handle. Cosec is the reciprocal of sine, so it's the same as solving the equation, sine theta equals a quarter. And then we just go ahead as normal. Okay, first or second quadrant. Acute angle 14 degrees 29 for this one. And so we end up with 14 degrees 29 for the first quadrant, and then 165.31 for the second quadrant. And then we mix it up a bit. So we've got 2 sine x plus 1. Well, it's just like solving any equation. We want to make the unknown the subject. But what we've got to remember with trig, it's the trig ratio is the unknown, not just the x. We can't factorize the sine, if you like, or divide by the sine. It's stuck with the trig. So I'll make sine x the subject, and we get minus a half, and then we just solve like normal. So third quadrant and fourth quadrant. Find the acute angle is 30 degrees. So I know it's 180 plus or 360 minus, and I get my two answers. Wow, 2 trig ratios. How am I going to handle with this one? Well, fortunately with this one, I can do it quite easily by dividing both sides by cos, or undoing cross multiplication, if you follow me, because I'll make it sine theta on cos theta is minus 2/5, but the sine theta on cos theta is, of course, tan theta. So now it becomes tan theta is minus 2/5, so second quadrant or fourth quadrant. 21 degrees 48 for the acute angle. Subbing it into our quadrants, we get the two answers. Now, the only thing, of course, we have to be careful with, and it's not an issue here, is the possibility of cos theta equaling 0. Because I can't divide by 0, of course. Well, not an issue, because obviously the cos of 21 degrees 48 is not 0, so it's fine. But should 0 had come up as one of our possibilities, I would have to discount that one, because it wouldn't solve the original equation. You've always got to go back to the original equation. Cos 2 theta. Now later on we'll see other ways of solving 2 theta. We can turn that into a single angle of theta. But at this stage, what do? Well, again, we've got to find the 2 theta first. I can't divide by cos, if you like. So I can't, in this one, divide by 2, because I can't pull the 2 out of the cos. So we actually find what 2 theta is first. But that requires another issue over here. The domain's between 0 and 360. Well, if I'm finding values for 2 theta, I've got to go further. Because if theta's going between 0 and 360, then 2 theta must go between 0 and 720. I've got to go around the circle twice. I want all the answers going around the circle twice. So it's still quadrants 1 and quadrant 4, that's still the same. The acute angle, 41 degrees 25, that's still the same. But it's now that 2 theta will be either the acute angle or 360 minus. So 2 theta will be 41 degrees 25 or 318.35, but I'm going around twice, so I add 360 to both of those and come up with 4 answers. The very last step in a question like this is to divide by 2. So once I've found all the answers, then divide by 2. I think the common mistake is once they've found the acute angle to divide that by 2 and then apply it. Wrong order. The last step is to do the division. So the last step. Oh, tan and sec squared. This is where our trig identities that we saw is going to come in handy. Because again, I don't want a mixture of different ratios, but I can rewrite sec squared in terms of tan theta. That's going to be a lot easier than trying to rewrite the tan theta in terms of sec. Yeah, I mean, I suppose it's possible, but it would involve square roots and things like that. So it's easier to change the sec squared into 1 plus tan squared. We create a quadratic equation, same as before, it's just that the pronumeral is our trig now. So multiplies together to give -2, adds together to give 1. And now we have 2 trig equations to solve. Tan theta is -2, or tan theta is equal to 1. So let's do the -2 one first. So quadrant 2, quadrant 4. Acute angle is 63 degrees 26. Plot them into our quadrants. There we go. It's only half done. Tan theta equals 1. It's one of our exact values. In the first and third quadrant, 45. Put them in. It's good to write a final answer down, I think. I mean, it shouldn't be up to whoever's marking your work to pull it all together. Yes, all the answers are there, but let's make it easy for them. Write a final statement. I personally like to put them in ascending order. Okay, so for G, let's play with some trig equations.